This is CPM Calculus, Chapter 2, number 68. Okay, so this one is saying if you plot finite differences of a parabola. Okay, if you plot finite differences of parabola, the result will be what type of function? So type of function. Okay, so first of all, plot. What's a plot? Well, we know we want to graph it. So we need our I cannot draw a straight line. Our x and our y axis, right? We want to plot a parabola. We want it to do we want to plot a parabola? No, we want to plot the finite differences of a parabola. We know parabola is like this or like this, it's our squared function. So finite differences. Finite differences are basically, for example, if we have y equals to x squared, okay, that's one parabola, right? And we have x and y, and then we have our finite differences. So I'm going to explain what it is with this example. Okay, so let's start with -4, -3, -2, -1, 0, 1, 2, 3, 4. Okay? So first of all, let's find out what's our y. So if x is -4, y is -4 squared, so that's 16. -3 squared is 9. -2 squared 4. 1, 0, 1, 4, 9, 16. Okay? So our finite differences, so finite just means like not infinite, right? It's measurable, and differences just means subtract. So to get the finite difference, we just subtract these numbers. So 16 minus 9 is 7. So our finite difference at -3 will be 7. We don't have one here because we didn't do -5. Okay? We could do that one, but we'll just skip that for now. Our finite difference at -2 is 9 minus 4 is 5. Okay? Our finite difference here is 4 minus 1 is 3. You see how I'm doing this? I'm just subtracting subtracting this number minus this number, you get the finite difference. 9 minus 4 is 5. 4 minus 1 is 3. 1 minus 0 is 0. 0 minus 1 is -1. 1 minus 4 is -3. 4 minus 9 is -5. 9 minus 16 is -7, and so on. So let's plot this. So this is going to be our x, and this is going to be our y, yes, but we're going to call it our finite difference as our plot. Okay, so our output is going to be the finite differences. So if x is -4, 1, 2, 3, 4, we don't have a finite difference yet, right? We could calculate that, but let's just plot the ones we have. So x is -3, we have 7. So 2, 4, 6, 8, 10, 12. Is that 2, 3, 4, 5, 6? Let's just make this 1, 2, 3, 5, 6, 7. So at -3, we have +7. That's our point, right? -3, comma 7. And I'm getting that from this is our x, this is our y value. Okay, because our x, we're plotting our finite differences. At -2, it's 5. So 1, 2, 3, 4, 5, -2. Okay, and -1, the output's 3. So -1, 1, 2, 3. At 0, our output is 0. Right? Oops. Sorry. 1 minus 0 is not 0, it's 1. So at 0, our output is 1. Okay, I made the mistake. Everyone see how 4 minus 1 is 3, 1 minus 0 is 1, not 0. 0 minus 1 is -1. Okay, so that looks good. So that's not, so our point is that Our points are so far -3, 7, -2, 5, -1, 3, 0, 1, 1, -1. So let me do this. 1, 2, 3, 4, 5, 6, 7. Okay. So we're going down 7, up 7. 1, our output's -1. 2, our output's -3. 3, our output is -5. 4 output is -7. Okay? Okay, so if we connect these dots, and if we did this on graph paper, and if you have a ruler, what you're going to do is these finite differences, what does that look like? They should be exactly straight. I am just not able to draw. So what type of function is the plot of our finite differences? Well, this is a line. Okay, so the finite differences of a parabola, right, is a line. And you can use any example. Your parabola could be y equals x squared plus 8x minus 25, right? It could be any parabola, as long as it's in the form of ax squared plus bx plus c. As long as we have some x squared term, we have a parabola, right? So any parabola is going to give us a line as the finite difference is plot. You can check different examples and you'll find that it's always going to be the case. So this ends CPM Calculus Chapter 2, number 68.